My turn, Liang here.
It
Just doing.
is.
Can you hear me? All right.
Can hear you fine.
Okay, good. Let me just share my screen.
If you're not the speaker, mute your mute.
Okay. Right. So, okay. So, today what I'm going to present is a dialect of fourth core Phoscript, right? And so basically, I started this project way back in 2017, trying to implement fourth on PHP and JavaScript. And so what I found out was something quite interesting, I would say, that you see way back in the 60s, Dijkstra, who invented algo and a lot of other legendary algorithms. Basically, he was the one who started what we call shunting yard algorithm, and eventually the shunting yard algorithm became the foundation of most of the modern compilers. Now, so I believe what fourth and other dialects are doing is actually the inverse. Although I have not seen anyone coin this name. So I will talk about that in more details. Then the second part of this discussion is about cryptography. And there are some very interesting relation between homoiconicity, that is like how we treat code and data as the same, and with cryptography, right? So basically there are some relationship between meta programming and cryptography. Okay, so now let's quickly start. I'm quite sure most of you know about this, right? So now the old shunting yard algorithm, all right, is this way. You have a infix notation 3+4, all right. You turn it into reverse Polish notation. That is sort of the input to the interpreter, whatever language we are doing. And the inverse is what fourth and all the other dialects are doing. And what I'm actually trying to do here is to use the high level languages. Now the reason I did this was because I way back in the 2017, I was in the mid 40s, yeah, just to let you know my age. And so I am sort of like a late comer to fourth, and so I try to learn fourth myself, and so I'm actually using this way to learn fourth. So I hope that eventually this can be a very interesting and perhaps easier way for other people to learn fourth as well. All right. Okay. So this diagram is basically how the inverse the shunting yard algorithm works. Okay. So now it's called shunting yard algorithm is because it's like the railway, yeah. But of course nowadays there are fewer and fewer railways people are seeing anyway. So maybe the younger people haven't seen a railway. I'm not sure how it works in operation. So you have these tokens 3+4, and then you move the token onto the stack. This is the data token, and then you move the operator to the other side, yeah. And then after that you move the second token 4 here. Then after that you evaluate this whatever items on the stack, and so to get back the results, yeah. And now this is the standard stuff that I'm sure every frog programmer understands. Okay, so this is the Merkle tree, which I will explain in the second part. Now, Okay, if you want to look at the details of this code, you can look at this link. Okay, I can't copy it. So sorry. Anyway, I'll post the PDF later so you can have a look in more detail. Now, what I'm trying to do here is that, okay, I'll just try to explain what I'm trying to do. At the beginning, this is a very simple demo of if I can click this I put it on the website, which you can actually try it out yourself even now. All right, I hope. Now let me just get the link for you. Okay, I will just put it to the chat area. Excuse me, can someone tell me how do I get back to the chat? All right, you see here. Yeah, okay, good. Now you can try this link yourself and you should be able to see this something like this, I hope. Okay. Now, so it's just a web page. Now, what it does is that I'm actually trying to demo. I am able to do a JavaScript and a PHP login, all right, using this kind of forth style language. Now, if I just click this off button, all right. Now, what it's doing is that it's actually sending a request to the backend, the server, and now then you get a string coming back here. So in terms of forth language, right? So what is going on is something like this. Okay, let me just get back to the slide. Okay, now, so when you click on this off button, what is actually going on? Okay, just a minute. Let me just. Right. Yeah, just the full screen is bringing some problem. All right, let's start again. Now, when you click on this button, what is going on is that it triggers this command here inside the JavaScript code. Now, I actually put the Phoscript command within this f function, right? I mean, it's just a there's no other name I like to use, so just make it simple. So it's authenticate. Yeah, it is A for alias. Now, and you can see here is the definition of this authentication. So I actually implemented the colon definition. So you can see it will call B colon, B off, and FO. Now, what it does is that B is actually a special function which controls two parts, right? The first part is the backend function, and then the second part is the front-end function. Now, if you are familiar with web page programming, then you know that all these web page operation, you need to perform operations in the front end and then the back end, and then come back to the front end. Now, so when I have this B colon, what it does is that it actually goes into this function here, okay, f underscore B, okay. So basically, what we are doing is that you can see that there are two types of function names here. One type is those with the colon. The other one is those without the colon. The one with the colon are the native function, which means that they are like based in JavaScript. All right, and then those without the colon are basically like our aliases or colon definitions, right, which are in themselves built out of the colon, B colon types of native functions. All right. So, and you can see that B of is actually defined here. Now, these are what they are doing is that to perform the backend function. And I won't go into details. And the purpose of this explanation is just to show that something that is familiar to all forth programmer, right? So what I'm going to do here is to implement the basic forth operations, okay? And finally, the FO part. Now, FO part is actually the front end output, right? So what it does is that you can see all this is a rather long operations, yeah. Now, so in fact, this is actually happening in all the web page programming, right? In the sense that we are I'm actually each of these word, all right, actually correspond to a JavaScript function itself. So basically, what I'm demonstrating here is that I'm able to map the forth style language to the JavaScript code in this way. All right. So just to recap what we have done so far, right? Right, if I can.
Obviously, they were there.
Sorry? You have a question, anyone? Okay, now, so what just to recap what we have done, all right, is just to, okay, I'll do this again. Yeah, if you can see, this is the front end, okay? And then you come back with the now. Now, I'll just do the next operation and we can move on to the next part of this presentation. Now, this gen key is actually doing something for a public key encryption. So it creates a pair of public key and private key. All right. Now, so that you can see that this long string is actually the public key. Okay. And of course, the variable name is PBK. Now, this is actually a very interesting way of doing login without a centralized login. Now, as you know, most of the system that we do today is a centralized login, like, your Gmail, you need to, all these logins is managed by a centralized server, okay? Right.
What cipher are you using?
This is actually basic RSA. It's actually available inside a JavaScript, right? Okay, you see in the JavaScript, if you can see this crypto, right? There is a library called crypto, right? It's all inside there, and there's plenty of. Now, in fact, the crypto library itself is actually quite complicated to use. All right, so what I did was that I actually yeah, right. This is it's interesting you ask the question. Now, this part, you see all this IMPBK, MK sign, SGC, right? All these that you are seeing here are actually Phoscript definitions of the cryptographic functions, right? So as you can see, well, I mean, it may not look so simple, but I assure you, if you try to implement it, I will say you can see that it's actually much simpler compared to the original number of lines that you have to deal with, right? Can you tell me how many minutes I have left for the rest of the presentation? Just to check.
What would
Kevin?
you like? Another 15 or
I have another 15 minutes. Is that right?
would you like 10 more minutes?
I have 10 more minutes. Okay. All right. Good. Okay. That's about right. Okay. All right. Right. So, okay. Okay. And any question before I proceed to the next part? Okay. Let me just, okay. Okay. So this part is, all right. Okay. Now, just now I just explained, the basic structure of, the basic operation of how how we can actually call JavaScript functions. Now, obviously, I haven't shown the PHP part, which is the backend, but it works in the same principle. Now, this is actually the core function. All right, what the core function does is this, and I'm sure all of you as fourth programmer knows this. So basically, it does two things: split space delimited string into a list of tokens. All right, then loop over the tokens, push data token onto stack, and evaluate or execute the function token. And that's it, really. Now, the good thing about this is that these steps, right, this core algorithm can be implemented in almost all known programming languages. Now, of course, it remains to be challenged. Is there any programming language that we cannot do this, because it would violate the Shunting Yard algorithm, right? So that would be a very interesting challenge in computer science. And the other interesting point is that any junior programmer, even if they just started learning the first programming language, and I have taught such students myself before, they will be able to learn, implement this within the first 3 months. Let's say they just learn Java programming language, they will be able to do this. Now, so what I find myself is that after I was able to put this in fact, as a sort of a middle-aged programmer myself, way back, when I was in the mid-40s, I find that this fourth thinking, fourth mindset is actually very helpful for me, right? To understand a lot of bomb problem, which of course one of them was cryptography, which I'll show next. Okay, now, so that algorithm for the core algorithm is shown here. All right, and okay, you can see.
You're muted.
Yeah, we lost your audio.
Oh, sorry, yeah, I just muted. Now you can see this file on I put it on GitHub. So what it does is that it start here, all right, and you can see that this is actually to split the string into tokens. Now, if you are familiar with PHP, you may recognize this explode function. Now, the reason why you see explode in JavaScript was that I tried to port the original PHP into JavaScript, and I don't want to change too many things. All right. So this is first part, and the rest are just housekeeping. So the next part that are interesting are these. Okay. So it's a do loop over all the tokens. And then the next part is this eval. Okay. If this function exists and so on, it eval. Now, so this is actually the part where it handles the what do you call it, the function token, all right, and it execute the functions, and then you put the result back on the stack. Okay, and now finally this is the part where you have the else part, putting all the data token. Now, so basically, this is really something simple that I would say can be implemented in all programming language, which is why, I mean, I was quite hopeful, like 7 years ago in 2017 that, to try to promote this, but there are a few missing pieces, which of course, prevented me to do that. And those missing pieces are the ones that I want to that I will explain to you today. Okay. Now, so before I move on to the cryptographic part, so as I'm sure you understand, all this issue, right? If we, so this is what I'm thinking, right? In a team, if we have this Phoscript, then we can basically split the job of the senior programmer and the junior programmer, into different tasks. So, for example, the senior programmer will be responsible to develop the host language interface. Yeah, right. Say for example, if you have a new language like Rust, Golang, or whatever, right? So you just focus on how to translate that function call to the Phoscript. Then the junior programmer will be able to focus on running those Phoscript, making it much easier. And hopefully they can pick up this API within 1 month. All right. I think this is something quite easy to do. Now what is interesting, I'm hoping, it can be applied is, you see, there are all sorts of very old legacy system like COBOL and Fortran. Now, theoretically, we can actually port this Phoscript onto old language as well. And it is systematic in the sense that every word, every function, right, can be tested, and so this become a systematic way of porting the language. And finally, of course, is this a problem called the transition of senior programmer. Now, I am not sure whether this is very critical over in US, but in Asia, it's really bad. Like people over 30 or 35 are seriously discriminated because they like to have this fire and hire policy, right? Fire old programmer and hire new programmers. But what I'm hoping this Phoscript can do is that to make the transition smooth, because even for the new senior program to pick up a new language should be much easier. Okay. And okay, so of course, so I said basically I have ported this Phoscript onto PHP, Python, Java, C++, and so on. So if you are all interested to look at this example in details, I can present them in the future. And obviously, the interesting part is that we can do this easily in all these new exotic languages. Yeah. Well, I just don't have time to do it myself, but if you're interested, we can collaborate. And the next part is, of course, abstract mathematics. And of course, and there is one thing that I have thought of and never have time to work on is to put forth in the browser, like Firefox. So if anyone interested, we can talk about it later. Sorry, Kevin, how much time do I have left?
Wrap it up now.
Okay. Yeah, I think I'll just wrap it up now because I think I just running into too much into this the detail of this Phoscript. Yeah, I don't think I have time for the rest of the cryptographic part. So yeah, so I think I'll just end here because it looks like yeah, okay, or maybe I'll just mention one more example before I wrap up. Okay. Now, so on this page, yeah, so this is a small project that I came across. I mean, I just thought of recently because of we have to deal with a big number in cryptography. So I started thinking, is there a better way to represent hash numbers, which are usually very large integers, 32 bits or 64 bits and so on. And then of course Don Golding, who was working on this Space Forth project and Core 1, I was inspired to think about how can we save space save more space storage in the space extraterrestrial. Now, so the idea was a bitwise stack machine where we use words I mean words as in, you know, the storage size, 8-bit, 16-bit, 32-bit, or 64-bit to represent the bigger number. Now, just to let you have an idea. Now, SymPy is a library in Python where you can manipulate things like prime numbers. Now, if you actually run this rank, okay, rank is, you know, when you put a number, then it means that the nth prime number. If you run it 12 times, you will get this huge number, which is 174 million, all right? And that is actually 28 bits. Now, which means if we can save this 12 bits, right? 12 bits is 12 steps is we can encode it in 4 bits. 4 bits versus 28 bits is a 7 times saving, right? And this is like a bitwise stack machine. Yeah, just an idea to propose to you know, anyone interested to work together. So I think I'll just wrap up my presentation here, and thank you very much.
Well, thanks so much. You're welcome to span next month. Please drop me a line. Unshare your screen at this time. I'd like to, Brad, are you ready to do the screenshot? Brad's muted, but he's saying something.
Sorry, it works better if we've got everybody full screen.
Okay.
Right. And
Turn
then
your camera on if you want to be part of the screenshot. If you want to be some kind of ne'er-do-well without your camera on, well, be that way. Hurt my feelings making.
yeah, don't be just a name. Be
Will be on the web page with the meeting.
all right. Last call.
We know who you are.
Okay, on the count of, all right. I would count, but it takes me a second to do the screenshot and then the section of it. So ready?
Say we're going to have the
So hold your position briefly.
camera down. Look up. All right, be that way.
All right. 1, 2.
Lunch. So we say,
3.
It's sort
Okay,
of not
I got it.
exactly it's going to happen. But as I said, lunch today at Armadillo Willie's to commemorate Dr. King's annual July barbecue. Brad, do you have Bill Wrightdale's video loaded?
I do. Let me see if I can do the audio correctly this time.
Hi, Doug Hammond. Are you coming to Willie's for lunch? Put a shirt on.
Okay.
You're very quiet, Doug.